Welcome to the second lesson on investigating geometry. I'm Eloise, and today we're going to concentrate on the maths tools needed to make conjectures and prove or disprove them. By the end of this lesson, you should be able to explain why definitions are important, what theorems are, give or read the coordinates of any point on the Cartesian plane, and recognize and describe reflective symmetry and translation. Today, we start straight away with these learners dressed as people doing different jobs. What do these jobs have in common? Look carefully. Did you notice that all these people have special tools that they use for their job? Whatever the job, people need the tools of their trade in order to carry out their tasks. And maths is no different. We also have tools which we use all the time. But most of the tools needed for maths are in our heads. The tool we use again and again is the knowledge of maths we already have, the facts on which we base our reasoning and conclusions. In the last lesson, we saw that Euclidean geometry is about points, lines, and shapes on a plane or flat surface. These give us practical mathematical tools with which to calculate things like the area of land or the volume of a structure. It also develops our skills in logical thinking and reasoning so that we can solve many of the problems we come across in life. And the starting point for using these tools is to know and understand definitions. We must make sure that we all have the same understanding of something before we can start making statements about it. Here's an example of a misunderstanding involving a quadrilateral and a parallelogram.
Huh? What do you mean it's a parallelogram? None of these sides look parallel to me.
You're right. I should have called it quadrilateral.
Gerard made the mistake because he was not sure of the definition of a parallelogram until Refilwe reminded him. But there's something else about definitions that make it all the more important to know and understand them. There can be several different definitions for the same thing. Take a look at this example.
This is the Mohale family gathering, and this is Bob. To Precious, he is a husband, but to Joy and George, he is a father. Yet to Madala Mohale, he is a son, and to Jeff, he is a brother.
There you saw several definitions for Bob, and all are correct. We will see later that polygons can also be defined in different ways like this. The next tools we commonly use in Euclidean geometry are theorems. Theorems are statements that can be proved to be true. Euclid shows that the truth of each statement follows logically from the truth of other statements and previously proven theorems. For example, you know that the sum of the angles of a triangle is 180 degrees. This is a theorem. It's a statement that can be proved to be true for all triangles in a number of ways. Here's another example. If you draw any rectangle and measure its diagonals, you will find that the diagonals have the same length. That fact can be shown to be true for all rectangles. Again, this makes it into a theorem. In his book, Elements, Euclid included over 300 theorems that were already known in his day. And a theorem, once proved, can be used to help prove another theorem. Thus, a theorem becomes a tool in itself. Now it's time to check that we have the basic tools for the other two kinds of geometry we're going to be using. Do you remember what this grid is called? If you said a Cartesian plane, you'd be right. Now, do you remember what these two lines are called? The horizontal line is called the x-axis, and the vertical line, the y-axis. And the point at which they intersect is called? I hope you said the origin. Now, what are the coordinates of the origin? Coordinates are the paired numbers that give the location or position of a point. And the coordinates at the origin are 0, 0. Now, if we were to move this way along the x-axis, what would all the x-axis coordinates have in common? They would be positive. For example, 1, 2, 3, 3.5, etc. So we are counting forward from 0 at the origin. But if we move left along the x-axis, the x-coordinates will all be negative. For example, -1, -2, and so on, because we're counting backwards from the 0 at the origin. Likewise, all the points above 0 on the y-axis are positive, because we're counting forwards from 0 at the origin. And all the y-coordinates below the y-axis are negative, as we're counting backwards from 0. Recently, our class had their photograph taken. Let's plot the positions of Cindy and Ranfus, our learners, using a Cartesian plane. To find Cindy, first we read her position off the x-axis, which is 7, and then we read her position off the y-axis, which is -4. So her position on the photograph is 7 minus 4. Now to find Ranfus, we do the same thing all over again, but this time in the opposite direction. First we read his position of the x-axis, which is -2, and then his position of the y-axis, 2. So his position in the photograph is -2, 2. Now let's see if you can give the coordinates of any point quickly. What are the coordinates of this point? Along the x-axis it's -3, and along the y-axis it's 1. So the coordinates are -3, 1. Now what are the coordinates of this point? On the x-axis we haven't moved from 0, so the x-coordinate is 0. And the y-coordinate is 2. So the coordinates of this point are 0, 2. Now for the last one. What's this? 4, 0, because the x-coordinate is 4 and we haven't moved on the y-axis, so the y-coordinate is 0. Being able to read and give the coordinates on a Cartesian plane is a basic tool you must have for working with coordinate geometry. When we use coordinate geometry in later lessons, we'll review a couple of other tools, such as how to work out the distance between 2 points. But for now, let's take a look at the basic tools of transformation geometry. Have a look at this honeycomb. What transformation can be seen in this pattern? This is an example of line or reflective symmetry. Can you see where the line of symmetry is? And what is the name of the line of symmetry in this particular example? This line of symmetry is the y-axis. You might know this as reflective symmetry or as line symmetry. Both names are fine because what we are saying is that something is reflected over a line. This shape has been reflected over the y-axis to produce a mirror image of the section on the left-hand side of the y-axis. Here's another example. Look closely at this pattern. What kind of transformation can you see here? See how this figure here has moved or translated to this position here, while the figure remains identical in shape and size. Don't forget, this kind of transformation is called a translation. There are other types of transformation that you may have learnt about in previous years, such as rotational symmetry and enlargement, but we'll leave those for now. Don't forget them though, as you'll be using them again next year. So, to sum up, by now you should be able to explain why definitions are important, describe theorems, give or read the coordinates of any point on the Cartesian plane, and recognize and describe reflective symmetry and translation. Well, I think that's quite a lot for one day. Next time we'll look at the tools we should already have relating to lines and angles. In the meantime, let's have a look at what's going on with Refillware and see if we can pick up any valuable tips.
Hey, what you up to?
My geometry homework, but it's taking forever because I keep having to look things up.
Can I give you a tip? I learned it from my uncle. It will save time and help with your geometry all the way till grade 12.
Please, G, I need all the help that I can get.
First, you need an A4 exercise book with at least 72 lined pages. It has to be a book, not sheets of paper like this. This will become your geometry theory book, which you can take from grade to grade until you leave school.
How's that going to help me?
Well, every time you learn something new in geometry, you can write it down in this book. And you can even use illustrations and diagrams, to help you remember the things that you learned. Then you keep a glossary at the back if you need to.
What's a glossary?
It's a bit like a dictionary, a list of words and their meanings. And leave the first 2 pages open. You can use them as content pages, index pages. And you can add to your content the more you write in your book. Keep a book like this starting now. And then in grade 11 and 12, you can use it to revise.
Thanks, G. That sounds like a great idea.
A valuable bit of advice for all our learners. Keep a notebook like that and it'll become a part of your toolkit for geometry. Your task for this lesson is to start your book by making a summary of everything we have reviewed so far. You may decide to call one section Euclidean geometry, another coordinate geometry, and the third transformation geometry. Until next time, goodbye.